We're looking at number 2, guys. We're going to write the equation of a tangent line. What 2 things do you need first? Point, slope. So I'm going to write down point, and I'm going to write down, oops, slope. All right. Do I know my x value for my point? Okay. Do I know my y value for my point? Yeah, you just plug it in right here, right? And you figure out what tangent of 0 is. Well, here's where 0 degrees is, or 0 radians, and that point is 1, 0. So remember what tangent is. Tangent is y divided by x, or sine divided by cosine. So what's 0 divided by 1? 0. So it turns out that this is 1 plus 0 raised to the 3/2, which is really just 1. Okay, so I've got my point. Now I need my slope. Well, it's the slope of this tangent line. Okay, the derivative, when I say derivative, you say slope of a tangent line. So all I'm doing here is putting in the derivative. Well, let me go to the side of my paper. If f of x is 1 plus tangent x, you're good, Eric. 1 plus tangent x raised to 3/2, okay, what's the derivative going to be? 3/2, beautiful. Very good. Leave the inside alone. Take the power down by 1. So what's that? 1/2, 3/2 minus 1 is 1/2. But don't forget, times, very good, times the derivative of the inside. What's the derivative of 1? 0. And what's the derivative of tangent x? Secant squared x times the derivative of x, which is 1, right? So then you don't have to put that 1. All right, because there's that du dx, right? Okay, but I don't want this in terms of x. This is the derivative, but I need to turn this into a number. And what I know is that everywhere there's an x, I'm going to put in 0. So you put in 0 there, and you put in a 0 here. Guys, what is tangent of 0? We figured that out up here. What was tangent of 0? 0. So all I get here is 3/2 times 1, because tangent of 0 is 0, okay? And then secant squared 0. Now be careful. Secant squared 0 is actually not 0. Isn't secant squared 0 equal to secant 0 times secant 0, right? Isn't that what secant squared is? It's secant x times secant x, okay? And if I go into my unit circle, there's no value for secant. So I need to go on my formula sheet and say, what is secant really equal to? 1 over cosine x, okay? So if this is secant x, it would be 1 over cosine x. If this is secant 0, it's going to be 1 over cosine 0. Does that make sense? Whatever number you have, that's the number you replace it with. So this is going to be 3/2 times 1 over cosine 0 times 1 over cosine 0. All right, when the angle is 0, what's my cosine value, guys? 1. So cosine 0, be careful, is 1. It is not 0. Sine 0 is 0, but cosine 0 is 1. And it turns out secant 0 is actually 1 over 1, which is 1. All right, so the answer is 3/2 for the slope, okay? So let's push this together. Y minus y is equal to the slope times x minus x. Make sure you understand, the tangent line gives you the approximation. This is going to help us to find the approximate answer. The real answer is always when you plug into your f of x, okay? So this is my tangent line. Let me go ahead and find what I'm trying to find. Oh, no, that's the answer. I can take out this 0, so there's my answer. Use the tangent line to approximate f of 0.2. All right, think about what this is saying, guys. This is saying when x is equal to 0.2, what's y equal to? Okay, can you interpret it like that? So it's saying use the tangent line. You actually have 2 equations that you could use. You could use this equation up here for f of x, or you can use this equation right here for y, okay? Remember, y is just an approximation of the real function, okay? And this is saying use a tangent line to approximate. And guys, the key word here is approximate. That's why you know you're going to plug into this tangent line. So wherever there's an x, I'm going to put in 0.2, okay? 0.2 divided by 2 is 0.1, so this is actually 0.3, so y is equal to 1.3. Okay, I did that in my head, but if you guys have a calculator, you're free to use a calculator. You just need to, make sure you know to plug it into the tangent line equation. All right, there's my answer. Okay, guys, if this is an approximation, let me write it to make sure you understand. What is my actual value? What did I actually approximate? I approximated this thing right here, right? This f of 0.2. what is the actual value of f of 0.2? How do I figure out what the actual value was? Plug it in up here. Does that make sense? To the real f, okay? So if I come up here and I plug in 0.2, 1 plus tangent 0.2 raised to 3/2. Let me see how far away I am from the real problem. Okay, guys, before you get started, please, please, please make sure you're in radian mode. Okay, if you guys are in degree mode, if you're in physics, okay, all of your numbers are going to be messed up. So I'm going to put 1 tangent of 0.2. Okay, let me figure out what that is. I'm going to raise all of it to the 3/2, which is really raising it to 1.5. Okay, that answer is 1.3189. Let me write that down here. My real value, I'll call that my actual value. I don't know what happened to my 1.3, but anyway, my actual value is 1.31899. You should go at least 3 decimal places. I'm just going to go more. And so here's my question. Which one's bigger, my approximation or my actual? Actual. So I'm going to put a less than sign like that. Everybody good with that? And guys, they always ask you if it's an underestimate or an overestimate, or they can ask you if it's an underestimate or overestimate. You want to put the approximation on your left and the actual on your right, because they're always asking, is approximation an underestimate or an overestimate? So guys, is this an underestimate or an overestimate? Under. Okay, and I know they're not asking this, but I'm telling you anyway, because you will be asked this on the test. If they asked you to justify this using calculus, what's the second derivative if your tangent line is an underestimate? Positive or negative? Positive. And why? And think about it, guys. When you have a graph that looks like this, okay, a happy face, this is your real function. If you put a tangent line on it, where does a tangent line go? Underneath it, okay? I saw yesterday somebody do this. Don't do that, okay? This is not a tangent line, okay? Tangent lines, like you pick a point and you put a line there. So guys, the tangent line is an underestimate. When your second derivative is positive, when your second derivative is negative, your tangent line is an overestimate. It's on top, okay? All right, the real question is, what is the error? You guys need to know how to calculate error. What you do is you just subtract these new two numbers. So I have 1.3189, and I'm going to subtract 1.3, and then you just put your error. So I put error is equal to 0.01899. And you really only have to go 3 decimal places unless they say otherwise. And I'll be real specific on the test, how many decimal places I want you to go, okay? And I did letter D with you guys. Right here, this is a less than sign. And then, yeah, you guys, I think you guys know all of this. The concavity is, wait, is it concave up or concave down? Concave up, and then you'll say F double prime is positive, okay? What does this tell you about the, I think that's it. All right, what other questions did you have? Did we want to do number 3 still? 3D. Does anybody need 3A? Okay, let's do 3A, and we'll work it through. Okay, here we go. dy dx. Okay, on most of the problems, actually all the problems, you didn't have to do implicit differentiation, but on this one you do. Okay, so what you want to do is isolate the y, but when you try to isolate the y here, you kind of like get a hernia. Okay, when you feel a hernia coming on, then you know it's probably doing something else. And so what we're going to do is we're going to take the d dx of both sides. Okay, on the left side, do you see that there are actually 3 different terms just strung together with a plus sign? Okay, what are you thinking? Are you thinking what I'm thinking? Oh boy, I thought I got to do 1 problem, but you get to do 3. Okay, oh boy, oh boy, oh boy. Okay, so right here, what's the derivative of negative 8x squared? Negative 16x. What's the derivative of 5x times y? Do you see it's 5x and y, like they're 2 product rule, right? So let's do it. Plus the derivative of the first, the derivative of 5x is just 5, times the second. What's the second? Do I need to put dy dx? Did I take a derivative with a y in it? No. When you just times the second, you just times the second. So it's the derivative of the first times the second. Okay, Sarah, are you good with all these problems? Okay, good. Plus the derivative of the second. What's the derivative of y? 1, but do you need a dy dx? Yes, so it's 1, but you need dy dx because you took a derivative with a y in it, and you're supposed to have only x's. So you have the derivative of the first times the second. No dy dx because you didn't actually take a derivative to get that. Plus the derivative of the second and then times the first. All right. And then finally, my last term, what is the derivative of y cubed? 3y squared. Do I need a dy dx? Yes, because I took a derivative and it had a y in it. Okay. And then finally, guys, be very careful. The number one wrong thing or the number one wrong answer that students put here is 1. What is the derivative of 149? It is 0. Very good. All right. So what I'm going to do here is my goal is to solve for dy dx. So I'm going to take everything that has dy dx. I'm going to put it on the left side. Okay. Everything that has that doesn't have it, I'm going to put it on the right side. But you have to use real algebra. Okay. You can't use the fake stuff. So if you change the side, you need to change the sign. All right. I have 2 dy dx's here. So my goal is to get dy dx by itself. And if I do that, what happens is I isolate it. I factor it out. Okay. And I have something that looks like this. Now, how do I finish up this problem? Divide both sides by what, guys? By that. Thank you. That's exactly right. Okay. All right. And so this is going to cancel out to 1. And so there is my dy dx. Can you guys check this for me? Okay. Good, bad, kind of. Okay. Guys, do you see I have more plus signs? Like I have 3 plus signs and 1 negative. So more than likely, if it's a multiple choice, they're going to leave it like this. Okay. They won't multiply by -1 over -1. The next question says, write the equation for the tangent line. Write an equation for the tangent line to the curve. All right, here we go. I need a point. And what else do I need, guys? Slope. All right, what's my point for -1? What's my slope? What is my slope? I need the slope of the tangent line. What is that? The slope of the tangent line. The derivative. Do I have derivative anywhere here? Yeah, right up here, okay? So dy dx is equal to -5. But are you guys okay if I plug in right now? The y is going to be -1. The x is going to be 4. The x is going to be 4. And the y is going to be -1. But -1 times -1, guys, is just +1. So what I get here is 5 plus 20 over 23, which is 25 over 23. Can I get a check from someone on that? Oh, okay, I did something wrong. Okay. Oh, thank you. Okay, 16 times 4 is 64. So now I get 69 over 23. Is that 3? Okay, thank you. All right, so that's letter B. The next question. Oh, sorry, you're right. Write the equation. So y minus y. So do you guys see that that's plus now, right? Because it's y minus -1 is equal to the slope. My slope is 3 times x minus x. Okay, and there's my equation, this black equation right here. All right, there's a number k such that the point 4.2 k is on the curve. Using the tangent line, approximate the value of k. Guys, they're just making this really hard. Guys, your k is really your y. Do you see that? They're saying if x is equal to 4.2, what is y? That's all they're saying, okay? And they're saying, which equation do you want to use? Do you want to use your real f of x or do you want an approximation? Use your tangent line. Which one do they say to use? The tangent line. So all I do is use this black box up here, and everywhere there's an x, I'm going to put in 4.2. So this will be y plus 1 is equal to 3 times 4.2 minus 4. So that's equal to 3 times 0.2 minus 1. Negative 0.4. Okay, negative 0.4. And that's my approximation. So actually, let me write it. Because after a while, I get confused, like, which one's the approximation, which one's the real? If you use the tangent line, that's an approximation. Everyone good with that? I mean, that's why this is called tangent line approximation. All right, part D says, and I know it looks very confusing, but guys, all part D is saying is, look, you know your x is 4.2. What is your y? Do you guys see it? Like, that's really what it's saying. It's saying, look, I know my x is 4.2. What is my k? But your k is just your y. Okay, what is your y? All right, guys, if I know my x is 4.2 and I want to find my y, isn't that what I did in part C? But my C was a what? An approximation. What if I wanted to find the real y? You have to go back to your original function. Does that make sense? And usually your function's really nice. But today, or on this problem, it's not. You're welcome. Okay, so all you need to do is come up here and find your y. And the easiest way to do that actually is just plug in. Everywhere you see your x, put in 4.2, okay? Everywhere you see your y, just leave it as y because that's what we're trying to find, okay? And our goal actually here is to figure out what y is, okay? Negative 8 times 4.2 squared, be careful with this. This is not 8 times 4.2. Are you guys good with this? Exponents before multiplication. So let me go to my calculator. This is going to be 4.2, square first, okay? Then multiply that by negative 8. So what I get is negative 141.12 plus, what's 5 times 4.2? 21, thank you. 21 plus 21y plus y cubed equals negative 149. Let me make this a little bit simpler because I've got a negative 141.12 here and negative 149. So that's 21 plus y cubed equals, does anybody know what that is? Say negative 149, oops, 9, plus 141.12. I'm going to add 141.12 to both sides. I get negative 7.88. So I actually need to find out what y is. There's lots of ways to do this. Let me just move everything to the left. 21y plus 7.88. Okay, everybody good with this? I'm just trying to solve for y. How would you solve for this? You can factor it, but it doesn't factor. Does that make sense? But you have a calculator. So go into your calculator. Let me hit clear. Go into your calculator, put in your y, put in your y1. But you guys understand, even though this has y's, if I make these x's, my calculator doesn't know that I'm really solving for y. Does that make sense? Okay, so shh, don't tell it, okay? I'm just gonna put in x's, okay? And I'm gonna make it work for me, even though it's not y. I mean, you could put in y's, but I don't know how it's gonna work because this is y equals. So you're gonna put in x cubed, okay, plus 21x, oh man. Okay, plus 21x, and then plus 7.88. Hopefully I did all that right. Okay, that's my equation. I'm gonna go ahead and graph it. Oops, I'm in the wrong zoom. I need to go to zoom standard, Okay, and how do I find where all my x's are or all my y's are? Isn't that just the intercept here? Okay, so let me see if I can find this intercept here. I'm only getting one value here. Actually, I don't really know what this looks like, but I'm trying to find this intercept here. So what you do is you go second, calc, 0. Everybody go with that, the x-intercept, okay? Your left bound, go to the left of your point that you want. So I want that point right there. So go to the left, hit enter. My right bound, go to the right of the point, put enter, and then when it says guess, just let your calculator guess, and there's my answer. That's my 0. Okay, so this is where this is equal to 0. It's x equals, but really I'm doing y equals. So y equals negative 0.3727714, and that's my answer. Okay, so this is the actual y value, and on part C, I did the estimate of the y value. Is that all for this question, or is there more? Okay, and what other questions do you need help with?
Ms. Chang, can you do 4?
Yeah, online guys, what question did you just ask?
Can you do 4?
Yes, they're asking 4 here too. Yes, let's do it. All right, I think number 4 is hard. But I'll tell you that you guys actually, when I show you how to do it, you'll be like, oh, I actually knew that. Okay, so let's look at this one. I need a linear approximation. Guys, when they say linear approximation, tangent line approximation, or linearization, it means all the same things. It means you need a tangent line approximation, so you need a tangent line. You need a point, and you need a slope, okay? Do I have a point? Yes, what is it? Okay, that's not bad. Do I have a slope? It doesn't look like I do, but you agree this is a slope of a tangent line, right? And what is the slope of a tangent line? When I say derivative, you say, okay, so all they want is a derivative, right? They want the derivative when x is what? 1. Is everybody good with that? Well, what is this picture over here? What's f prime? It's the derivative. So does this tell me what f prime of 1 is? It's not an f picture. It's not an f picture. It is an f prime picture. Does that make sense? It's my boy f prime. Okay, my boy f prime is back. Okay, so right here, when x is 1, guys, what is f prime? 2. So you actually know the slope even though you didn't know you did. Okay, so now I just put it into the equation. Y minus y is equal to the slope times x minus x. All right. And the first thing they tell me to do is estimate. I'm using linear approximation. So using this tangent line that I have, everywhere there's an x, put in 0.9 and find what y is. This one is saying everywhere there's an x, put in 1.2 and find what y is. Okay, so let's do it. Y minus 5 is equal to 2 times 0.9 minus 1. And what is 0.9 minus 1 really? Is it negative 0.1? So that's negative 0.2. So y is equal to 5.2. Okay, so this right here, let me make sure you understand. This is an approximation. Let me. Oh, it's not. Is it 4.8? Okay, sorry about that. 4.8. Okay, and that's about what f of 0.9 is. This is an approximation. So let me just write that. Make sure you understand. This is not the real value. I used the tangent line to get it, so it's an approximation. And then you can do the same thing, and I'll let you guys do it. Do the same thing, put 1.2 here, okay? And find that one. Okay, so the next question. Is my estimate an overestimate or an underestimate? And the problem here is I never knew what my boy F is. If I know my boy F, and unfortunately he's right now in another room, but if I knew him, then I could figure out what F is, and I could figure out if it's an under or over approximation, but I don't. But I do know F prime. So this is kind of interesting. Remember what I said, how do you figure out if something's an overestimate or an underestimate? Okay, so if this is F, this is concave up, right? So if F prime is positive, then what do I have? An underestimate, okay? If F prime is negative, then I have an overestimate. Well, I don't know my F. I actually don't even know my F prime. But up here on my picture, what do I do know? I'm sorry, I don't know my F double prime, but I do know my F prime. Does that make sense? So you have to go back to what relationship do you have between F double prime, F prime, and F? Do you remember? The second derivatives test. When F double prime is positive, F prime is increasing, and F is concave up. When F double prime is negative, F prime is decreasing, and F is concave down. Now remember what we said. This, if it's in the same row, they are all the same. Like they are absolutely all true if it's in the same row. All right. Do you see if F double prime is positive, then what is F prime doing? Do you see I have a picture of F prime? Guys, what is F prime doing? It's decreasing. So do you see that F prime is decreasing? So therefore F double prime is what? Negative. So I know that F double prime is negative. So this is not true here. F double prime is negative. I have an overestimate. And the reason is because F double prime is negative. Or actually, I guess, actually, that would be a totally acceptable reason. You could say also because F prime is decreasing, okay? But in our book, F prime decreasing is the exact same thing as F double prime negative, okay? Do I have a part C on this question or not? Nope, okay. What other questions do you guys have? Number 5, okay. So let's look at 5. Okay, guys, you have a question on your test almost exactly like this, okay? And the biggest problem with this question is that students look at it and have no idea where to start, okay? So can I encourage you guys, when you see tangent line approximation, please just put point and slope, okay? We'll figure things out as we go. Point and slope. All right. This is the problem where I told you guys, you have to figure out the point and you have to figure out the function. Okay, usually it's given to you, but it's not. So what you do is you find your funky number and put it in X there. The thing about this problem is there's not really a funky number. There's only one number. Well, guys, put in X there. Okay, that is your function. You have to figure out your own function, and that is your function. How do I figure out my function? I go find my funky number and I put it in X. Okay. Now I need to also figure out my point. Okay. So let me think about what this is really a picture of. This is the square root of X. And we've done this problem before. This right here is 53. So here's 53. Do I know what the square root of 53 is? No, not unless you're Albert Einstein. Okay, nobody knows what the square root of 53 is. So I can estimate it by getting a number that's close to 53 that I actually know the square root of. Think about what you know. What's the number to the left of this that you might know? 49. What's the number to the right that you might know? 64. Does everybody see we're getting the 49, 64? Those are numbers that you know the square root to. Now what you have to do is you have to be strategic about this. To get the lowest error, you need the closest number. So which one's closer to your 53? Your 49. So guys, I'm going to use 49. And what does that mean when I say I'm going to use 49? I'm going to go up here, draw a point at 49, and that's going to be my tangent line. Guys, if you don't practice this, if all you do is this one worksheet, you're not going to be able to do this on your test, okay? So please make sure you practice this. So this right here is a tangent line. What is my x value? 49. What is my y value? 7. Do you guys see how that works? Okay, be careful. The number one thing wrong thing, students, here is they switch it around. You can't switch it around. You got to get the right x value, and the x value must be pulled off your x-axis. Okay, the y value must be pulled off your y-axis. All right, now I need the slope, okay? But the slope is really the slope of a tangent line, which is really just the derivative, okay? So let's go ahead and do the derivative here. You need to rewrite this to x to the 1/2. So the derivative is equal to 1/2 x to the negative 1/2. I think I'm doing that right. And so that's 1/2 x to the 1/2, which is 1/2 square root of x. Okay, we've done this enough times that it should look familiar, that you could look at it and be like, oh yeah, I remember this. This is right. The derivative of square root of x is always 1/2 square root of x. But guys, I can't have x's in my slope. So what is my x here? 49. What's the square root of 49? 7. What's 7 times 2? 14. So this is 1/14. Okay? Then write your tangent line. Here we go. Y minus y is equal to the slope times x minus x. You can do it. All right? So the question is, how do I approximate the square root of 53? Now be careful. Don't put square root of 53 here, because you need to put an x value. What's the x value I'm going to put in? 53. Do you see? You have to pull it from the x-axis. I'm going to plug it into this black line. And the function of this black line is y minus 7 equals 1/14 x minus 49. That's the black line function. So I'm going to plug it in. 1/14, 53 minus 49. Is that 4? Yes, I think so. That's 4/14. Y equals 4/14 plus 7. Okay. 4/14 is really 2/7. Okay. So I'm getting 7 and 2/7. That's what my y is equal to. If I wanted to, I could do you remember how you do improper fractions? You do 7 times 7 is 49, plus 2 is 51/7. And that is my y value. That is my approximation. You guys also have a calculator, so if you feel more comfortable with your calculator, feel free to do that. Okay. And so that is my approximation for square root of 53. Let me see how far off I am. This is like the fun part. This is a fun part to see if I'm going to get the second date or not. Here we go. 51/7 is equal to what? 7.2857. Now, is that the real value, the actual value, or is that the approximation? Let's clear this up. This is the approximation. I got it from the tangent line, so let me just write that down. This is the approximation. All right, so the approximation is 7.2857. It actually helps if you put the approximation on your left side. Okay, on your right side, let's put your actual value. What was I actually trying to take the estimate of? Square root of 53. So square root of 53, let's put that into my calculator. Let's see how close I was. Not bad, not bad. Okay, I'm looking at 7.2280. Which one's, is this an underestimate or an overestimate, guys? All right, I think the approximation is bigger, right? So it's an overestimate. Okay, let's think about this. Overestimate, what's f double prime? Negative. Okay, so that should be somewhere in one of your questions. Using calculus, is the estimate greater or less than, you're going to say less than. I would just say it's an underestimate. Wait, is it under? No, it's over. Overestimate, because F double prime is, did you guys tell me negative? Okay, negative. And guys, go look at your curve. You can look at your curve and tell. Guys, is that concave up or concave down? It's concave down. So of course your tangent line is above, okay, your line right there, your red line. Okay, did we finish this problem? Okay, are you guys feeling good? All right, what other questions do you have? They actually worked on at home. What, Christian? You need 6. Oh, you haven't worked on it. Okay. Yes. Mm-hmm. Mm-hmm. Yeah, ln of 0.9 would be your actual. Does that make sense? And ln, so let me look at number 6 real quick with you guys. If you look at ln, do you agree ln looks like this? This is number 6. Okay, what's this point here? You guys have to memorize this. What's this point here? Do you remember from ln? 1, 0. Isn't that the point that they gave you? Okay, so what they're saying is draw a tangent line right there. Draw your tangent line. Oops, my tangent line's not good. Okay, let me see here. Draw your tangent line. Okay, I can already tell you, is this an underestimate or an overestimate? Overestimate, you guys see that? So you already know a lot of the answers, okay? What are they trying to tell you to put, what number to put in for your x? So this is your x-axis. What number did they say? 0.9, and what other number? 1.3. Those are x numbers, right? Okay, go figure out what your tangent line is here, okay? So you have a point and you have a slope, okay? Go for it. What's the derivative? Remember, y is equal to ln of x, or f of x is equal to ln of x. So what's the derivative of this? Nice. And I think you know your point, right? 1, 0. Okay, I'll let you guys go from there. Yes. Okay, I'm going to walk around, guys. If your homework is done, please just